starting now. Alright, so let's try to move on to a different part. Okay. So now the second part, this is where you have an acid now. Let's say you have 0.134 molar concentration of HCl as an acid. Right? So we are expected to calculate the pH and as well as what? As well as the pOH there. So what did we say about the pH? So we said, first of all, look at what you have in this case. You have an acid. So do you have the hydrogen concentration or the hydroxide concentration? What do we have? So if you write the dissociation reaction, you know that HCl is a strong what? Is a strong acid. So this is just going to be the hydrogen and the chloride ions in the solution. So meaning that in this case what you have is the concentration of the hydrogen ion. So you're able to find the pH. So our pH is going to be the negative log of what? It's going to be the negative log of 0.134. So you find your pH there. So in this case you say your pOH is going to be 14 minus what? Minus your pH there. Any questions there? Do we have any questions?
No.
Okay, let's look at 3 more questions that are going to give us a better understanding on this topic that we are talking about. But before that, just one more on the same basic idea of determining the pH. Now in a case where it is not in the same ratio, let's say you have 0.030 molar concentration of barium hydroxide. So let's say that's what we have. How do you get to approach that question? So first of all, we'll write the dissociation reaction, which is going to be what? So you're going to have barium plus 2 hydroxide ion. So this is a different case from what we've been talking about. Remember, if you look at the first 2 examples, we just add them in the ratio of 1 to 1. Now in this case, what do we have? We have the barium hydroxide itself, where we are given its concentration to be, it's in the ratio of 1 to 2 compared to the hydroxide what? Concentration. So what we have here is 0.03. So if you are saying 1 to 2, you have a ratio there 1 to 2. Then since the concentration of the barium hydroxide is 0.03, we can find also a concentration of hydroxide ion concentration in the solution. So our value of X is going to be 0.06 molar concentration. So in this case, instead of you working with the actual value given there, you're going to use that. This only applies if either the hydroxide or the hydrogen concentration are in the different ratios from the base and the acid respectively. That's when you get to do or work with the ratios. So therefore in this case, since we have the hydroxide concentration, we will also first of all find the pOH by just saying the negative log of the concentration that we found. Then for the pH on the other hand, it will require you to subtract from 14. Then you'll be home and dry. Okay, let's try to look at now some practical examples. That is going to be a very general concept that you're going to be we are going to be working with as we get to talk about the different equilibriums. So let's look at this question as our practice question. So in this question we are required to calculate. So I'll write the question: calculate the hydronium concentration. So whenever you see anything in these kind of brackets, just know that they are talking about what? Concentration. So calculate the hydronium concentration in 0.20 molar concentration of what? Of acetic acid. So this is where now these are the most common questions that you should be expecting. So given that the value of K is equal to 1.8 by 10 to the power negative 5. So under this topic we are going to be dealing with values constant K's. Yeah, of course, yesterday I did mention that when you have an acid dissociating, what we get to have as the value of K in such a case, it's Ka. If you have a base dissociating, what you get to have is what? Kb. So basically when you're talking about acid and base equilibrium, we are very much focused on what? Weak acids and weak bases, because these are the guys that don't dissociate completely, they dissociate partially. Okay. So before it gets to proceed, we have to write the equation, the dissociation equation. So we have acetic acids. So of course the formula was given. So it is dissociating in what? So dissociation is going to be occurring in what? It's going to take place in water. So we'll show that to show that it's incomplete dissociation. So now we have an hydronium ion forming there. Why is it forming? It's because the water molecule in this case is going to gain a proton from what? The acid, because we are saying an acid is basically a proton donor. So there will be gain of an hydrogen there. Plus, we're going to have the acetate ion, meaning that the acetic acid is going to lose what? A hydrogen there. And that's what we're going to have. So we work with what we call the ICE table, which shows the initial concentrations, the change, and also the equilibrium concentration of the different reactants and products that you have in a reaction. So in this case, if you look at the question, what were we given? We were just given the... What were we given? We were given the concentration of the acetic acid. So we have... So I'm saying the ICE table. So ICE. So what was the initial concentration? Here we had what? We had 0.20 molar concentration. So if you look at the water there, here we're saying it's a liquid. So under equilibrium, guys, you have to understand that concentrations, basically when you are trying to look at, of course, the main essence of using the ICE table is we want to find the value of K. So basically, when finding constants under equilibrium, we don't consider the concentration of the liquids. We only look at gases and what? And aqueous states. So of course I need to mention that this is in aqueous state, the water is in liquid, the hydronium is in aqueous, the acetate is also in aqueous. So the liquid part is not going to be part of the ICE table. So remember, knowing that in this reaction, in this dissociation reaction, we only started with acetic acid. So initially, remember this I is representing initial concentration. So we didn't have any concentration. So we had zero concentration of those two guys there. So now the change, what do we get to put for the change? So what I'm talking about now also applies to, it's very applicable as we get to talk about chemical equilibrium, as well as we talk about the solubility expressions, the Ksp value. So what we have is look at the stoichiometric coefficients here. So it's 1 1. So we'll say we are going to introduce a variable x, then it's going to be multiplied by the stoichiometric coefficient, then we add a negative for the reactants since they tend to reduce in a chemical reaction. So these are going to be positives because we expect them to increase after the reaction has started. So they are just xx because they are in the ratio of 1 to 1. The stoichiometric coefficients are 1s. Okay. So what are we going to have as our equilibrium concentration? So equilibrium concentration involves you adding the initial concentration with the change. So on the part of the acetic acid, we are going to have 0.2 minus x, then the other part x and x, because 0 plus x is just x. So now I want you to understand this important fact that whenever you are trying to find the value of k, it may be your kp, it may be your kc, or the ka, or the kb, whatever value of constant that you're going to be finding under this topic. It is a requirement that your value of k is basically dependent on the product of the product of, because the reason why I'm trying to avoid saying that is because I'm going to repeat two words. It involves you multiplying the product's concentration. So in this case we have the hydronium ion and what? And also the acetate ion as our products. So the product of products divided by what? Divided by the reactants. So in the reactants we're just going to show 1 because we don't show the liquid. Okay. So what does that mean? So that means that in this case what we're going to do is we're just going to divide. Okay. So our value of k is going to be, so what we have as, remember the values of k are going to be dependent on the equilibrium concentration. That's why we look at the ice table, because we want to find the equilibrium concentration. So it's going to be, for our products we have x and x there. So x times x is x squared over 0.2 minus what? Minus x. So if you look at our question, we were also given the value of Ka, which is 1.8 by 10 to the power negative what? 3. So we can find the value of x. And the good part is we don't want to come up with a quadratic function. So whatever is added to a constant or subtracted to a constant, we cancel it out. So that is going to be cancelled out. So that we just multiply, we cross and multiply, then find the square root of our answer there. So what do you get to when you multiply 0.2 by 1.8 times 10 to the power negative 3? Then you find the square root, so that we find the value of x there. Have we understood what I've said there? So this multiply by that, then you find the square root, so that we find the value of x. Which part? Which part should I repeat? I didn't get you. Okay, so I was saying, in a case where you have a square there on top, the addition of a subtraction, or in fact it may be down, but provided there is an addition of a variable x or subtraction to a constant, we cancel it out. So now at this point it's going to be x squared multiplied by 1, that is there, then we are crossing and multiplying, so this 0.2 is going to be multiplied by what's on the other side. That's what I said. Does that make sense now? Does that make sense? What are you saying? Oh, it's basically -5. Okay, -5, sorry. Yeah. So have we understood that we cross and multiply there? Then you find the square root. Are we okay? I've emphasized on that point. I've said we've cancelled it out. Yes. Because if we don't do that, we are going to come up with a quadratic equation. And we don't want that, because if you look at the value of the k there, it's too small. So it's just going to be a sheer waste of time, because whether you consider it, you can even try it out, you're still going to find the same solution. You're going to find the same value of x. That is not going to affect the solution. So what are we getting after crossing and multiplying? What are we getting? I help you. So make sure every time we have a class, you have a calculator with you. So our value of x is basically going to be 1.897 times 10 to the power -3. Okay. So that is our value of x. So now, yeah, you're right. So now, if you go back to our question, the question was asking us to find the hydronium concentration, right? So which is that? So the equilibrium concentration is x. So now that we found the value of x, that is basically our solution. But in a case if they had asked us to find the concentration of I don't know if you are I don't know why you are repeating. I don't know if my network is slow. Yeah, but you've repeated that. Yeah, I did confirm, but it's that's the same solution that we have. Yes. (1.9 times 10 to the power negative what? Is this what you're getting? Hello? Yeah, so I was asking, is that what you're getting? Okay, I don't know if it's your network or it's my network, but it's taking time for you guys to respond to what I'm saying. Okay, so what we have here is our concentration, and that is our solution. Okay, so it's very, very important for you to understand how you get to work with the ice table. Okay, that is the approach that you get to work with. So I did share yesterday a link to the video that has got more practice problems on the same concept here, and they're very useful. So if you didn't watch it, I would advise you watch it. Basically, this topic is the shortest topic under equilibrium, acid-base equilibrium. Very few concepts to understand. And of course, I did talk about the ion product, where we said it is a product of Ka and what? And Kb. Okay. So I'm sharing some practice questions just now. So this is where we end, unless if there are any questions. Then please, like I requested, share the notes for the solution and their properties, so that we can do that tomorrow. And also the tutorial sheets that you have been given, share them so that we can solve them. Are we together? Even math, I did request for the notes, but I didn't receive anything. And the tutorial sheets. So good night, everyone. Good night. Hello, can you get me? I'm not getting any response from anyone.